Hello student, let's try to understand one derivation. Prove that Cp minus Cv is equal to R. So if you talk about Cp minus Cv equal to R, so student, these things you try to understand. This is the gas constant, universal gas constant. That is one thing. This is the heat capacity at constant volume. So I am writing heat capacity at constant volume, and this is what a heat capacity at constant pressure. So that thing you need to keep in mind, student. Before studying these things, you should know some terms. What is total heat content? This is the no total heat content at constant pressure, equal to, it is going to be enthalpy. Okay, it is equal to always enthalpy. That you need to understand, and this is what you can write, that is qp. Next one is there, student, the second terms which is important, total heat content, at constant volume. That is what the second point we are going, total heat content at constant volume, that is qv is equal to internal energy delta u. Okay, so these are the note. To understand this topic you should know this, the crux. Okay, these things are there. Now student, let us try to understand what is the, in the term of heat capacity we are going. So cp is equal to what is, student? It is going to be qp upon delta t. This is one thing. Now you can cross multiply, qp is equal to, it is going to be cp delta t. Similarly cv is equal to qv upon delta t. This is heat capacity at constant volume. So qv is equal to, it is going to be cv delta t. Up total heat content at constant pressure, just now I explained, total heat content at constant pressure is equal to delta H. This is equal to delta H, and this is equal to what? Delta U. So this is the equation 1, and this is going to be equation 2. That you keep in mind, student. Now the second point, from the equation of enthalpy, so what is the equation of enthalpy, student? Delta H is equal to delta U plus delta NGR delta T. This is what is we are having equation. So delta H value, from here you can put, what we can do, put Cp delta T equal to delta, here you have qp. So this value delta U is equal to what is there, student? Cv delta T plus delta Ng, this is the G in the gaseous phase, R delta T. This is equation number 3. They are saying what, student? Divide equation 3 with what is, student? Delta T. Okay, so if you are dividing this equation, student, Cp delta T upon delta T equal to Cv delta T upon delta T plus delta Ngr delta T upon what is going to be, student? Delta T. Dear student, delta T cancel out. So Cp is equal to Cv plus delta Ngr. Now for 1 mole, what is, student? What you can write? Delta Ng is equal to going to be 1. So Cp is equal to Cv plus R. So Cp, this side you take, Cp is equal to R. Cp minus Cv equal to R. So this is all about the answer, student. I hope this will be this you will understand. So two things required, student. First point, you should know what, that is total heat content at constant pressure is enthalpy, total heat content at constant volume internal energy, and enthalpy equation delta H is equal to delta U plus delta NGRT. Without knowing these three things you can't do anything. Heat capacity formula, heat capacity at constant pressure, total heat content at constant pressure, no, heat required at constant pressure to raise the temperature of substance by 1 degree Celsius. So this is the Cp, qB by dt. So just try to understand, it will be okay, student. Thank you.